This is algebra 2, factored form of a quadratic function. Corey wrote an equation factored. So Corey's equation was y equals x plus 8 times x minus 2 to represent a quadratic function equation. Kimberly wrote an equation of y equals x squared plus 6x minus 16. And Josh wrote a quadratic equation of the form y equals x plus 3 quantity squared minus 25. Now, we've worked on two of these. We've worked on Kimberly's already, which is in standard form, which is standard is y equals ax squared plus bx plus c. And we've also worked on Josh's form, which is vertex form, which is probably the best form, vertex form. And it's y equals a times x minus h quantity squared plus k. Today we're going to be working on this one, which is called factored form. So all three equations represent the same function. So for example, if I take Corey's, which is this one right here, and multiply it, distribute it, and I think I showed the box method to everybody, and I'll show it again, and take x plus 8 times x minus 2, x times x is x squared, x times negative 2 is negative 2x, 8 times x is 8x, and 8 times negative 2 is negative 16. And we're able to combine those two. So when we do that, we end up getting x squared plus 6x minus 16, which is the same as this one, as Kimberly's, okay? And then if I take Josh's, which is in vertex form, which is x plus 3, y equals x plus 3 quantity squared minus 25. And now I've got to multiply this here out, x plus 3 times x plus 3. I'll do it over here. And I get x squared, x times 2 is 3x, 3 times x is 3x, and 3 times 3 is 9. Combine those, so we get y equals x squared, and I combine those two, plus 6x, plus 9, and then I've got my minus 25, so I'm going to add these two together, so I get y equals x squared plus 6x, and 9 minus 25 being negative 16. So you'll notice it's the same as Kimberly's up here too. So they are the same equation, just in different form. Okay? Let me make this up a little bit so I can get just a little bit more. So now it asks, how could you determine if the three equations represent the function? You could also graph, they could graph the three equations. on the same plane. And you get the same graph, of course. On the same plane, where's that? Okay, same coordinate plane. One information can Corey's form help you find it is more difficult to find using Kimberly's or Joshua's? Well, the thing about Corey's that's really better is Corey's form. Corey's form, which is what we call a factored form, help you see where the graph of the function will cross the x-axis. Okay? But notice x plus 8, it crosses at negative 8. Remember, when it's in a parentheses, we've got an imposter, don't we? And we got another parentheses that intersects at 2. So instead of it would be 2 there. Okay? So which one was the vertex form? I think I've already said, but I'll make sure. Vertex form is Joshua's, correct? Joshua's, which was y equals x plus 3 quantity squared minus 25, and the y-intercept form, they call it, which I call it standard form, they call it y-intercept form, is Kimberly's, which is y equals x squared plus 6x minus 16. And again, I think I've showed you this, when it's in standard, I call it standard form, they call it y-intercept form. Always remember that it's always 0, c. So the y-intercept for this one here would have been 0, negative 16. And then the x-intercepts are Corey's, which he had y equals x plus 8 times x minus 2. So that's intercept form. Now I'll review this again, but we worked a ton on factoring. So again, when this leading coefficient is 1, you really don't have to split the middle. A times C is 12, and B is 7. So what I'm trying to do, this is A times C, so A times C. I need to know the factors of 12, and the factors of 12 are 1 and 12, 2 and 6, and 3 and 4. Which one of those factors add up to 7? Of course, it's 3 and 4. So when this is a 1, you can do a process called unfoiling. So all you got to do is this, put x here and x here, and plus 3 and plus 4. So when you can split the middle like I showed you in class, but when this leading coefficient is 1, I would just unfoil it like this. You can go ahead and split the middle if you want. I'm just trying to give you tricks to make things faster for you, okay? Okay, the next one, factor. Notice this one here, A is greater than 1, so we have to split the middle. So I take 2 times negative 3 is negative 6, and B, of course, is negative 5. I need to know the factors of negative 6 that subtract give me 5. Well, it would be negative 6 and 1. Let's check it. There's always a check. Does this times this give you that? And does negative 6 plus 1 give you negative 5? It does. So when I split the middle, I bring the outsides down. So it gives me 2x squared and negative 3. And then I split the middle. I split this middle with these two numbers. So it would be negative 6x plus 1x. And then now I've got 1, 2, 3, 4 terms. So I'm going to group these two together and these two together. So when I group these two together, I factor out the GCF, which is 2x. Which leaves me x minus 3. And then this one here, the only factor they share is a 1, so I still factor it out. And you see now that they share these two, don't they? So we know x minus 3 is going to go in front. And then I would always X these out and look and see what's left over. It would be 2x plus 1. And there you go. Now, you have not seen one like this. This is a binomial, and we've got a couple. We're going to end up this year having 4 different ways to factor a binomial. But the only one you're going to have to know how to do is what's called the difference of squares. And the difference of squares is a squared minus b squared equals a plus b times a minus b. So this one here, this is how my teacher taught me. Put a plus here and a minus here, an x here and an x here. Why? Because x times x gives me x squared. And then what's squared gives me 9, that's 3. And there it is, I'm done. That's simple. So that's how you factor a binomial when it's the difference of two squares. Notice I said difference, this has to be a minus. Notice this one here, we have to split the middle. So the factors, looks like we've already done this one up above, so I'm not going to redo it. We did it up above. We already got this in there, so I don't know why we duplicated that. Okay, let's go to example 2 now. The graph shows that the function divide by x squared plus 2x minus 8. How do the zeros of the function relate to the factors of the expression y equals x squared plus 2x minus 8? Well, if we factored this thing here, if we factored this x squared plus 2x minus 8 over here, we unfoil it, then we need to know the factors of 8 that subtract to give me 2, and of course it is 4 and negative 2. So when we unfoil this, using these two factors, I get x plus 4 and x minus 2. And what you notice is your x-intercepts, if you look at the graph, is negative 4 and 2. They're imposters again, aren't they? And what you can do is your x-intercepts are negative 4, and your zeros, we call them zeros, are x equals negative 4 and x equals 2. So when we write this thing, we got y equals x plus 4 times x minus 2. Let's plug in our 0 in for x and see what we get here. Okay? So we get y equals negative 4 plus 4 times negative 4 minus 2, which is equal to 0, and then times negative 6, and of course that's 0. That's why it's called a 0. And then we plug in the other 0 too into this for x right here. We get 2 plus 4 times 2 minus 2, which is 6 times 0, which is 0. Okay, that's why they're called zeros. Now, what it does is it relates the factors x plus 4 times x minus 2 are related to the zeros x equals negative 4 and x equals 2, since each since each of the zeros make one of the factors 0. Like here, this first one we put in -4. What did we get here? We got a 0. In the other equation we put in 2. What did we get here? A 0. So example 2, try it. The graph shows the function defined by x squared minus 9x plus 20. So let's factor this baby out here. So we've got 1 times 20. We're going to unfoil. And we got to get the factors of 20 that add up to give me -9. Of course, that's -5 and -4. So when I factor that, that would be x minus 5 times x minus 4. Okay? Now let's look here. Where does it intersect the x-axis? Well, the factors are x minus 5 and x minus 4 are related to the zeros x equals 4 and x equals 5. Since each value of x makes one of the factors 0. So for example, here's our function, okay, in factored form. So we know one of our zeros is 5. So if we put in 5 there, put 5 there, sorry, make it 5. What do we get right here? We get, there's your 0 again. 5 minus 4, doesn't matter what you're going to get because the whole thing's going to end up being 0. And the same way plugging in 0 over your 0 over here for the other one. Plug in 4. Again, I get 0, don't I? Correct? Okay. Zero product property. The zero product property states that if a product of real number factors is 0, then at least one of the factors must be 0. In the case of two factors of a times b equals 0, then either one of those could be 0, or both of them. To use the zero product property, rewrite this equation so that it is in expression equal to 0, then solve and factor. Factor and solve. Okay? Okay, so solve by factoring. So the first thing you have to do is to solve by factoring is set equation equal to 0. So on this one here, we're going to have to subtract 42. Then you're going to factor it. So we can unfoil this baby. -42 and 1. So 7 and -6. So then this thing factored to x plus 7, I'm unfoiling, times x minus 6. X plus 7, x minus 6, okay? Then use the zero product property. Use zero product property. So what I do is I take each one of those factors, I take that x plus 7 and x minus 6 and set equal to 0. Subtract 7, so x equals -7. Add 6, so I get x equals 6. So I solved it. That was the last thing I did, which I did right here. I solved those two. So there are my zeros. -7. So if I graph this quadratic equation right here, and if you want to do it in Desmos, you can. If I put y equals x squared plus x minus 42, you'll see it intersects the x-axis at -7 and 6. This next one, again, I've got to set everything equal to 0. So I'm going to add 9x over here, and I'm going to subtract 5 over here. So those end up canceling over there. So I get 0. So it gives me 2x squared plus 9x minus 5. Okay? Okay? So I got to split the middle on this one because a is greater than 1. So I get -10 and 9. So factors of 10 that subtract give me 9. It would be 10 and -1. So I bring the outsides down, and I split the middle with 10x minus 1x. So I'm going to group those two, and I'm going to group those two, correct? So I can take a 2x out of this one. That gives me x plus 5. And I can take a -1 out of this one. It gives me x plus 5. These two better be the same, and they are. So I pull those out in front. And then what's left over are these two. So it'd be 2x minus 1 equals 0. And then I set each one of those factors equal to 0. Okay? So I get x plus 5 equal to 0, so I'm going to subtract 5. So there's x equals -5 for that one. And then 2x minus 1, I'm going to add 1 to both sides. And then divide by 2, so I get x equals 1/2. So my zeros are 1/2 and -5. 1/2 and -5 are my zeros. So if I graph this parabola, this 2x squared plus 9x minus 5, it will intersect the x-axis at 1/2 and -5. So let's do these triads. I'm going to subtract 20 because I got to get it set equal to 0. So x squared plus 8x minus 20 equals 0. So factors of 20 that subtract give me 8. And I'm going to say 10 and -2. So then I'm going to unfoil the x plus 10 and x minus 2. So I'm going to set each one of those equal to 0. Subtract 10. X equals -10. Add 2. So x equals 2. So there are my zeros. X equals -10 and x equals 2. Those are, if I graph this parabola right here, it would intersect the x-axis at -10 and 2. This one here, I got to get everything on one side. You know, I'm going to always set it equal to 0. So it gives me 2x squared minus 3x minus 2, right? Those all canceled over here, and then I get everything on the left side. So I need to know the factors of 2 times -2 is -4. That subtract give me 3. So it'd be -4 and 1. Let's check it. Here's your check every time. Does this times this give me that? Does this and this add up to give me that? And it does. So I bring the outsides down. Then I split the middle with -4 and positive 1x. So then I'm going to group these two together, and I'm going to group these two together. So I factor out a 2x out of the first one. That gives me 2x, which is times x minus 2, plus 1 times x minus 2 equals 0. These two are the same. And it gives me 2x plus 1. And then now I set each one of those factors equal to 0 and use zero product property. Add 2. So I get x equals 2 for this one. X equals 2. This one here, I'm running out of room. I'm going to subtract 1. So it gives me 2x equals -1, and I divide by 2. So I get x equals -1/2. So for this one here, your zeros are 2 and -1/2. Move this up a little bit. So I end up getting 2 and -1/2 for zeros for this one. Okay. Anna solved the equation by factoring. She wrote it x minus 10 and x plus 2 and expected x-intercepts of the function to be at negative 10. Was this correct? No, she was not correct because she didn't factor it correctly. The factored form of the equation is x plus 10, x minus 2. Notice I got negative 10. I can check real quick. If I do my negative 20 and my 8, this has got to be 10 and this has got to be negative 2, because 10 minus 2 gives me 8 and 10 times negative 2 gives me negative 20. He used, or she used, negative 10 and 2. Well, negative 10 times 2 does give me negative 20. But those two, negative 10 and 2, don't add up to positive 8. They add up to negative 8. Okay? The equation form of the equation is x plus 10. Now, she got the right zeros, didn't she? She got the right intercepts, but she had it in factored form wrong. So the factored form isn't right, which is this is the correct one, but the x-intercepts are correct. Okay? So this next one here, example 4, says a multi-level driving range has 3 levels. Marco hits the balls from the second level, which is 32 feet high. Notice there's your starting height right there. And after Marco gets the ball muddled by this thing, which is 32 feet, and then this is her function relative to how high the ball goes, and this here gives you the time, when does it hit the ground. So when it hits the ground, the height has to be 0. So we're solving this equation right here. We want to know when it hits the ground. Okay? So what I'm going to do first is, if you've got any equation in which you can factor out a number, factor out a GCF to get things a little smaller, it makes life a lot easier. So then I have this negative 16 times this quantity, and then this here I'm going to factor over here on the side by unfoil. Okay? Because if I would have used these two numbers, I would have had to split the middle, but it would have been a huge number. So I like, if you can ever factor out a constant out, makes life a lot easier. So this is going to be negative 2 and positive 1. So this whole thing factors to this, x minus 2 times x plus 1. So now I use zero product property. I take negative 16, and I set it equal to 0. Of course, negative 16 can never equal 0, so I just forget about that. And then I said x minus 2 equal to 0, so I add 2, so I get x equals 2. And then x plus 1 I set equal to 0, and I subtract 1, I get x equals negative 1. Now remember, x represents time. Can you have negative time? Can you have, I got negative 1, you cannot have negative time, so you can throw that one out. So this one here is your answer. Now what does it mean? When does the ball hit the ground? It hits the ground in 2 seconds. 2 seconds. So x equals negative 1, it can't be negative time, so it has to be 2. So he hits it, and it takes 2 seconds for that ball to hit the ground. Okay, example 4. A ball is thrown from the upper deck of a stadium 120 feet above the ground. Notice there's your 120. How long does it take for the ball to hit the ground? Again, we're going to solve this equation right here. And we set it equal to 0 because we want to know when it hits the ground, which the height would be 0. So again, I'm going to factor out a negative 16. And then I'm going to look to unfoil this one. So we've got negative 8. Factors of 8 to subtract give me negative 2, so it's going to be negative 4 and positive 2. So when I unfoil that baby, that's going to be x minus 4 times x plus 2. So here it is, completely factored. So then I set each factor equal to 0. So I set negative 16 equal to 0. Of course, negative 16 can never equal 0. Then I take x minus 4 and set it equal to 0, and x plus 2 and set it equal to 0. Okay? So, add 4. So get x equals 4. Subtract 2. X equals negative 2. Now, we got two solutions, but again, you can't have negative time. So you're going to throw that one out. So what does that mean? It takes it 4 seconds for it to hit the ground. 4 seconds. Okay, identify the interval on which y equals x squared minus 2x minus 3 is positive. Factor and find the 0. So let's first, step 1 is to factor. So I'm going to unfoil this thing. Okay? Unfoil it. So, negative 3, 1 times negative 2. So it's going to be factors of 3 that subtract give me negative 2 would be 3, would be negative 3 and 1. Let's check it. Does this times this give me that? Yep. Does this and this give me negative 2 and add them together? Yes. So I factor it to be x minus 3 times x plus 1. X minus 3, x plus 1. And then I set each one of those equal to 0. X minus 3 equal to 0, and x plus 1 equal to 0. Add 3, I get x equals 3. Subtract 1, I get x equals negative 1. Okay? So what I want to do here is, they want you to find, test these intervals, pick a point in each interval and determine if it is positive or negative. So if we graph this parabola, we want to see the interval in which it's positive or negative. Positive means it's above the x-axis. Negative means it's below the x-axis. So you could see it with a Desmos or a graphing calculator. But this is what I do, is take 0 and then you've got 3, correct? So I'm going to go 1, 2, 3. There's one of your zeros right there, okay? All right? And then the other 0 is negative 1, which is right here. Okay? Now the reason why I'm doing this gives you 3 intervals you got to check. You've got to check this interval from here out to here, which is x is less than negative 1. Everything out here is less than negative 1, okay? And then here is negative 1, the interval between negative 1 and 3. Okay? All non-included because there's not an equal sign. Okay? Because on this x-axis or on this number line, you're neither positive or negative. So you have to use parentheses, not equal signs. And then over here, the intervals from x is greater than 3. So what you're going to do is in each one of those intervals, you're going to pick a number and plug it in up here and see what you get. Okay? So out here, x is less than negative 3. I'm going to choose a number, and I'm going to use negative 3. Again, you can use negative 2, you can use negative 10. I just choose negative 3. And I'm going to plug it into this equation and see what I get. So I get negative 3 squared minus 2 times negative 3 minus 3. So I get 9 plus 6 minus 3. So 9 plus 6 is 15 minus 3 is 12. Correct? 12. So here we got positive 12. So in this interval, it's going to be positive. We plugged in a number in that interval and we got a positive. Now let's pick a number over here. I'm going to choose x equals 1 because 1 is between the negative 1 and 3. Okay? So I plug in 1, I get 1 squared minus 2 times 1 minus 3. Agreed. Over here I use x equals -3, correct? So here I'm going to choose x equals 1. So 1 squared is 1. -2 minus 3. So I get -4, which is negative. So this interval from here to here is negative. Okay? Now we're going to pick, we have the next interval, which is x is greater than 3. So I'm going to pick, I choose 6. You could choose 4, but I choose 6. X equals 6. I'm going to plug it into my parabola, or plug it into my quadratic equation. So 6 squared minus, notice I'm using this one right here, minus 2 times 6 minus 3. So I get 36 minus 12 minus 3. 36 minus 12 is 24. 24 minus 3 is 21. Okay? Which is positive. So here it's positive. Okay? So they want to know, pick a point each and determine if it is positive or negative on that interval. Okay? Alright? So they asked up here if it was where it was positive. So it's positive on the interval x is less than -1 and x is greater than 3. So if you did an interval notation, it would be -infinity to -1, non-included, and 3, no, these should be ors, 3 to positive infinity. There's where it's positive. Okay? Now, you could have done this. Notice, I could have graphed that quadratic equation. Remember that quadratic equation was y equals x squared minus 2x minus 3. Okay? And I factored it, if you remember, I factored it down to x plus 1 times x minus 3, correct? And if you'll notice, we graph this parabola, it intersects at -1, right? And it intersects at +3. We wanted to know where it was positive. Well, it's positive up here, and it's positive up here, isn't it? Well, this is the interval from -infinity to -1, correct? And then out here is positive infinity, so it's 3 to positive infinity. Okay? All right, let's do another one here. A little drink. So this next one, first we're going to factor it. So we get -21 and -4. So it's going to be -7 and +3. Let's check it. This times this give me that. Yep. Because this and this add up to give me that. You bet. So this one here, when I unfoil, would be x minus 7 times x plus 3. So on my intervals, I like to put 0, 0, 1, 2, 3. There's a 1 where a 0 was at. And then the other one's -7. So 1, 2, 3, 4, 5, 6. -7's right here. Okay? So we have 3 intervals we got to check. We got to check x is less than -7. X is between -7 and 3, not included, and x is greater than 3. That's the other interval. Okay? So I'm going to plug in over here. I'm going to choose hold it. I screwed up, didn't I? Wow. You gotta wake up. I didn't set those equal to 0, did I? Correct? I should have x minus 7 set it equal to 0, so I get x equals 7. Set x plus 3 equals 0, and I get x equals -3. So my here's 0. 1, 2, 3, 4, 5, 6, 7 is right here. and then negative 3 is right here. So my intervals are x is less than negative 3, and between negative 3 and 7 is from here to here, and then x is greater than 7 is from here to here. Okay? So I'm going to choose out here negative 5. I'm going to choose x equals okay, so I'm going to plug it in. So y equals, I'm going to plug it in right here, negative 5 squared minus 4 times negative 5 minus 21. This gives me 25 plus 20 would be 45 minus 21 would be 24. So I get 24. So this one here is positive. And then this one here, I'm going to plug in, I'm going to choose 0 for this one. It's in between, choose x equals 0. It's in between an interval. So I get y equals 0 squared, so I'm plugging it in there, minus 4 times 0 minus 21, so I get y equals negative 21. So this one here is negative, this interval. Okay? And x is greater than 7, I'm going to choose 9. Choose x equals 9. So that's 9 squared minus 4 times 9 minus 21, correct? So that's 81 minus 36 minus 21. I got 81 minus 36 is 45 minus 21, which is positive 24. So this one here is positive. Now this one they wanted to know where it was negative at. So it's negative at on this interval right here. So it's negative between negative 3, x is greater than negative 3 but less than 7. The interval notation would be like this, negative 3 to 7, both parentheses. And if you graph this thing, you would see that it's probably, it would be, your values would be negative between these two, so the parabola's vertex is sitting down here, something like this. Okay? Okay, it says, is it always true that the y values of a quadratic function have opposite signs either side of the 0 of the function? Explain why or give a counterexample. Remember, for geometry, if you can find one example that proves what your hypothesis is false, then it's called a counterexample. And this one is no, because for the equation, quadratic equation, y equals x squared, all y values are non-negative. Okay, so is it always true that the y values have opposite signs on either side of the 0 of the function? No, that's not true. All y values are non-negative. You plug them in there. Okay? Okay, example 6. Write an equation of parabola with x-intercepts at negative 2, 0 and negative 1, 0, which passes through the point negative 320. Factored form of quadratic is this right here. So this is what you need. This is factored form. Okay? Factored form. That's important. Okay? So, first, you want to write the general form of a factored equation. Okay, so y equals a times x minus p times x minus q. So what I'm going to do is I'm going to label everything. Negative 2 is p. Negative 1 is q. Negative 3 is x. and 20 is y. So again, like I had to do in standard form, I got to find a. So I'm going to substitute for these variables here and solve for a. Substitute -1 and -2 for zeros. Your zeros are P and Q. And then I'm going to substitute, and I'm also going to substitute -3 for x and 20 for y, as I labeled them here, okay? So let's do that. So y is 20, a is going to be my unknown, x is -3, minus p, which would be minus a -2, and then I'm going to have x again, minus q, which would be minus a -1. So that gives me 20 equals a times -3, so that's going to give me -3 plus 2, because a minus, that gives me -1. Okay? And then -3, this gives me -3 plus 1, which would be -2. So I'll multiply those two together, that would be 2a. I don't write a2. I write, this is -1, so I put the 2 in front, then I divide by 2, so I get a equals 10. Now I can write my equation in factored form. Y equals 10 times x plus 2, it was minus 2, so it was an imposter inside the parentheses, and then x minus a -1, which would be x plus 1. And there it is, in factored form. It asks in habits of mind here, is there any other parabola with x-intercepts -2, 0, and -1 given equation explained? Yes, there could be, right? Any equation of the form y equals a times x minus p times x plus x minus q, which in this case it was this, right? A times x plus 2, x plus 1. There's another parabola it could be. Say a was 5. It still has those same intercepts. It's just not going to be as vertically stretched as the one up here with 10, but it still has the same intercepts, doesn't it? Okay? Now let's try example 6. Okay, x-intercepts, this is p, this is q, this is x, this is y. So our standard form, factored form I should say, is this. So again, I'm going to have to find a, so y is 2, a is my unknown, x is 1, minus 3, and then 1 again, x is 1, minus a -3, so 2 equals a, 1 minus 3 is -2, and then 1, this ends up being 1 plus 3, right? 1 minus a -3, which would be 1, which is 4. So when I multiply those two together, I get -8. So I don't write a -8, I write -8a, -2 times 4. And I divide by -8. So a equals -1/4 when I reduce this fraction. And now I can write my factored form. Y equals a is -1/4 times x minus 3, it's an imposter, times x minus a -3, which would be x plus 3, and there it is. There it is in factored form. Okay, I think here's standard form and here's factored form. Okay? And then we worked on finding the zeros by using zero product property, and we put those points. Here's our zeros, correct? Right? Right there and there. Negative 7 halves and 0. And it's positive everything out here and everything out here, isn't it? And it's negative everything down in this area. So the intervals where the function's positive from negative infinity to negative 7 halves and 2 to positive infinity. It's negative between negative 7 halves and 2, which is down here. That's what we've done so far. Okay, how is the factored form helpful in solving quadratic equations? The factored form is helpful because you can use it, in the zero product property to find the zeros of quadratic functions. Remember, the zeros are where it intersects the x-axis. Find the zeros of quadratic equations. Amir says the graph y equals x squared plus 16 has negative 4 as a zero. Is Amir correct? No, he's not. And you'll learn here before long that this parabola does not intersect the x-axis. I want you to think about it. It's shifted up 16 units, right? 1, 2, we'll go by fours. So this is 4, 8, 12, 16. It opens up. Well, it does not intersect the x-axis, so there's no real solutions. So Amir is not correct. There are no real solutions. To the equation zero equals x squared plus 16. Remember, we can factor the difference of two perfect squares, but we can't factor the sum of two squares. Okay? How does the factored form of a quadratic function relate to the zero product property? When a quadratic equation is written in factored form, each factor can be set equal to 0 to find zeros because of the zero product property. Zero product property. Okay? How does the zeros of a function help determine whether a function is positive? Okay, remember we had a parabola earlier, looks something like this. And we should know that everything up here and up here is positive, right? And everything down here is negative, correct? So the zeros of a function are the only points where a function can change from positive to negative and vice versa. Or negative to positive. So, you can separate a function into intervals separated by the zeros. And any point within an interval will have the same sign. Okay, again, we'll do some more factoring here. Factor, since this is 1, we can unfoil. So negative 24, negative 5 factors of negative 24 is subtract giving 5, it would be negative 8 and positive 3. So when I unfoil, it would be x minus 8 times x plus 3. That's unfoiling, and that's a 1, correct? And then the next one, I have to split the middle on this one because leading coefficient is greater than 1. When I say leading coefficient, that means A. So it's, 10, negative 10 when I multiply A times C. Factors of 10 that subtract give me 3 would be 5 and negative 2. Here's your check. Is this times this give me negative 10? And is this minus this give me that? So, bring the outsides down. Split the middle with these two numbers. Okay? Then group these two together and group these two together so I can factor out of this one a 5x, which gives me x plus 1. And then these two here I can factor out a negative 2, which also gives me x plus 1. And then I take the x plus 1 out, and that leaves me 5x minus 2. And there it is. Okay? I was just factoring on those. Now if I want to solve, then I have to do one more step. First I got to get everything on one side. So I'm going to bring my 12x over here, and I'm going to bring my 20. I'm going to get everything on the left side. Those cancel, don't they, and leave me 20. Excuse me, not 20. Come on, Donnie. Gives me 0, doesn't it? That's what I want. So I can use 0 product product, and then x squared minus 12x plus 20 on that one. Okay? Since this is a 1, I can unfoil. So 1 times 20 is positive 20. Factors of 20 that add up to 12. Add up to negative 12, right? This is A times C, and this is B. Factors of 20 that add up to negative 12. Let's see. 10 and negative 10 and negative 2 will work, or negative 2, negative 10. So that factors to x minus 10 times x minus 2. I got it factored. Now I set each one of these equal to 0 and use 0 product property. So I add 10 to both sides. I get x equals 10. There's one of our zeros. And then I add 2. So x equals 2. Those are other zeros. Okay? This one here, I'm going to have to subtract 6. Cancel, cancel. So it's set equal to 0. So I have 4x squared minus 5x minus 6. This one I have to split the middle because the leading coefficient is greater than 1. So 4 times negative 6 is negative 24. And I need to know the factors of 24 that subtract give me 5, so it would be negative 8 and positive 3. So let's go ahead and bring the outsides down. And then I split the middle with negative 8 and 3, so it'd be negative 8x and plus 3x. Now I group these two together and these two together, so I can factor a 4x out of the first one, which is the GCF, which gives me 4x times x minus 2, and then this one here I can factor a 3 out, which also gives me x minus 2. These two are the same, and my teacher used to do this to me, x that out, what's left over, 4x plus 3, correct? Now I got it factored. Now I'm going to solve it by using zero product property. So I said x minus 2 equal to 0 and 4x plus 3 equal to 0. Add 2. So x equals 2. Subtract 3. Divide by 4. So x is equal to negative 3/4. So I get negative 3/4 and 2 for my zeros. Negative 3/4. And 2. Okay, it says this, the height and feet of a t-shirt launched from a t-shirt can is given by this equation. How long does it take before the t-shirt hits the ground? So that means my height has got to be 0. So again, I like to factor if I can at the beginning. If I can get a constant out, I like to do that. It gives me smaller numbers. Okay. Then I factor this one. I can unfoil, right? Factors are negative 5. That subtract and give me 4. Be negative 5 and positive 1. So that would be x minus 5 times x plus 1. So I got the negative 5 here. And I got the positive 1 here. So now I said each factor equal to 0. So can negative 16 equal 0? Of course it can. I said x minus 5 equal to 0 and x plus 1 equal to 0. Add 5. So I get x equals 5. Subtract 1. X equals negative 1. I cannot have negative time. So how long will it take before the t-shirt hits the ground? 5 seconds. There's your notes. I'll put this in Schoology for you. For you to refer back to help you with your homework. Thank you.